I'm Anil Kumar, sharing with you a test question on application of vectors. So you're working with position and velocity. The question here is, an object initially at 510 moves with velocity vector 3i minus j. Determine the position of the object at any time t in minutes, the time when the object is due east of 0, 0. You can always pause the video, answer the question, and look into my suggestions. Now we need to find position of an object. So the position of an object in terms of x and y, where both are functions of t, both are functions of time, could be given as the initial position, we'll call that x0, y0, plus t times the velocity vector. Right. We are given the velocity vector here. The velocity vector v could be written as 3 minus 1. Does make sense to you, right? So 3 minus 1. So 3 along x, 1 minus along j, y. So the position vector could now be written very clearly, which is, at times we prefer to write like, okay, so we say position vector as a function of x, which is also a function of time, and y, which is also a function of time, right, is equal to, so initial position is 510 plus t, and the velocity vector is 3 minus 1, correct? So that becomes the position vector. Now, second part of this question is the time when the object is due east of 0, 0. Now, what does that mean? Okay, let's try to understand this position. So let me sketch. Okay, let me sketch here. So, now, in these situations, normally we consider t, where t belongs to real numbers. It is not mentioned here, but normally we say t is greater than or equal to 0, right? Okay. And the units are given to us as probably meters, I don't know. Okay, not given, so we'll not write them. Fine. Anyway, so the position here is 510. It really means 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's my initial position. So let me write this as position A. Now as I give different values of t, I get new positions, right? For example, this is for t equals to 0. If I write 1 here, then that really means I have to move 1 unit to the right, 1, 2, 3, and 1 unit down. So I get the next position. 1, 2, 3, 1 down. 1, 2, 3, 1 down. Like this. So you see that we're kind of moving in this direction. Is it okay? So let me break the scale here. So somewhere down the line, we are going to cross this line. This is my 0. So wherever you cross this line, let's say you cross it here somewhere, at that time you are due east of 0, 0. So we are looking for x-intercept. So that means a position where you cross x-axis, which represents time for us, in minutes. Does it make sense? So this actually represents time in minutes. So if you find the x-intercept, so we have to find x-intercept basically. So I hope you got the concept. At x-intercept, y value is 0. Correct? So the position will be some x value which we want to find, but the y value is 0. You get my point. That is what we're looking for. Correct? So if I write this in in parametric form, it'd be easier for me to find. So I can write this as x of t. I could write this as equal to 5 plus 3t, and y of t as 10 minus t. Now we want this y of t to be equal to 0. So that means 10 minus t equals to 0, and that means t equals to 10. Do you get an idea, right? So that means t is equals to 10. So what is x of t? So at t equals to 10, x of t equals to 5 plus 3 times 10, which is 5 plus 30, which is 35. So that point, if you break the scale, will be 35. Now look back at the question. It says the time when the object is due east of 0, 0. So our answer is right there. 10 minutes. So now we can write down the answer, which is after 10 minutes. Right? It'll be due east of 0, 0. Does it make sense to you? So after 10 minutes. Now, how far will it be? Which is not being asked here. Will be 35 meters or whatever units, right? 35 units, let me write here. Which is not being asked. But sometimes that may be important. Anyway, so I hope you have understood how we can relate position of an object in R2. Thanks for watching. All the best.